Okay, so first of all, I'm really happy to see so many of you here today. So thanks for signing up, and also thanks to Center for Sea and Society for inviting me to speak today. As Per mentioned, I will talk about my study here. That was also my master's thesis. And in this study, I analyzed offshore wind farms, fisheries, and fish stocks in Skagerrak, Sweden, around 3 planned wind farms. So just quick information on who I am a bit more deeply. I have a bachelor in physical geography and ecosystem science, and this is where I gained my GIS knowledge. And then I continued with a master in Sea and Society here at the center. And I took some time between starting and finishing my master's. So I worked for a couple of years, and then I got back to the university last year to finish and to write my master thesis on wind farms and fisheries. And it was already mentioned, but currently I'm working as a GIS expert at the County Administrative Board. Yeah, so my presentation will be for around 25 minutes or something, I think. And then we will have some time for questions and a bit of a discussion. And for some housekeeping, you can ask questions in the chat. And since we're quite few people here today, I think Per and the other organizers will help to bring them up in order. So we'll have some structure about that, but you're very welcome to just write questions in the chat throughout the presentation. So before I start with the details of my study, I would first like to identify the Sustainable Development Goals that can be related to the study. And I found that my study aligns with several goals. Firstly, SDG 7, Affordable and Clean Energy. And it aligns with this goal by exploring the role of offshore wind farms in promoting clean energy production. Secondly, we have SDG 14, Life Below Water. And the study aligns with this goal by evaluating the potential of offshore wind farms to conserve marine ecosystems and regenerate fish stocks. Moving on to SDG 8, Decent Work and Economic Growth. And the study aligns with this goal by assessing the socioeconomic impacts on the local fishing industry and the potential for sustainable livelihoods in coastal communities. And finally, we have SDG 14, and that is Partnership for the Goals. And I identified this goal since my study identifies the need for strategies that enhance collaboration between different stakeholders. So this was just a quick overview of the related SDGs, and I will end my presentation by trying to come back to these goals and how they relate to the findings of my study. So, electrifying Sweden. Well, Sweden is amid an electrification process to meet its goal of net zero greenhouse gas emissions by 2045. And this increasing electricity demand requires a doubling of Sweden's fossil-free electricity production. And here, offshore wind farms are playing a key role in this large-scale transition. And why is that? Well, the process from permit to construction is relatively short for offshore wind farms comparing to other energy sources. And the cost for both construction and the energy from wind farms is amongst the lowest of all energy sources. In addition, it has high efficiency in production and also a relatively low environmental impact. And that makes it quite an attractive choice. The long coast of Sweden with steady winds also allows for favorable conditions for establishing offshore wind farms, both on the west and east coast. But so the establishment of renewable energy production in form of offshore wind farms is essential for a sustainable future, but it can also create conflicts, and especially spatial conflicts with, for example, the fishing industry. And that you will see an example of soon. So, as I mentioned, my study is set in Skagerrak, and the Skagerrak is the sea on the west coast of Sweden. And this area is really a hotspot for wind farm establishment, and many wind parks here are currently applying for permission to operate. And I have focused my study on the area of and around 3 planned wind farms. So I defined the study area as the wind farm area and 10 kilometers around each wind farm. And one of these wind farms was actually granted permission to operate, or permission to construct and then operate a couple of weeks ago. And then the 2 other ones are still undergoing the review process and are awaiting a decision. So none of them are built yet. I want to say that to make things clear, but they are in the process. And now to the spatial conflicts. The Skagerrak is also a very active fishing region, and especially for trawl fisheries. It's actually one of the areas in Europe where bottom trawling is most intense. And in the areas around and inside these wind farms, the target species for bottom trawling is Nordic shrimp, Norway lobster, and different demersal fish species. So as you can see on the map, you can see where the different target species can be found. And as I said, the map only includes catches up to 10 kilometers around the wind farms, because this is the defined study area of the study. But you can see that there are intense patterns of catch both inside and around the wind farms. And the thing is that bottom trawling is a fishing method that is not compatible with offshore wind farms. So therefore, we can identify some spatial conflicts here. But at the same time, all of these stocks that I mentioned, the Nordic shrimp, the Norway lobster, and the most common demersal fish species, have shown negative trends during the last decades. And the status of these ecosystems where they live is not very positive. The Marine Strategy Framework Directive of the European Union states that the marine environment must be protected and preserved to achieve environmental status. And this is currently not fulfilled in Skagerrak, and nor is fulfilling the SDG 14, life below water. So clearly conservation of the marine environment in this area is also needed. So I started to think that since offshore wind farms is not compatible with bottom trawling, and bottom trawling is one of the biggest threats to the stocks, maybe then the offshore wind farms actually can help to conserve the fish stocks and the marine environment. So, in fact, when looking at previous studies, many studies indicate that the offshore wind farms might benefit fisheries and regenerate fish stocks. So in the same way that I was thinking. But how is that then? Well, being areas that are incompatible with bottom trawling, it provides a relief for the benthic ecosystems and the stocks that exist there. This allows for regenerative effects and such as spawning, abundance increase, and individual growth. And this may then lead to spillover effect. That means that when you have individual growth, or population increase within a specific area, after a while, this may spill over to surrounding areas, also benefiting the fisheries and fish stocks there. So by looking at these previous studies, I got even more interested to see and to explore the long-term impacts on fishing opportunities around these different wind farm sites. And I wanted to analyze if the establishment of the offshore wind farms potentially could be an incentive to transform to a more sustainable fishing industry by catching in a more limited area, and maybe also convert to passive gear that are compatible to use within a wind farm. So in other words, I aim to assess if the offshore wind farms could be a step towards conservation of degraded ecosystems and depleted fish stocks, and at the same time allow for some sustainable fishing practices, not including bottom trawling. But I also wanted to hear the fishermen's perspective on this topic and also learn more about the socioeconomic impacts. So to do this, I needed to use an interdisciplinary method. It consisted of two parts. The first part focused on calculating the change of total catch in the study area, and the second part included interviews with local fishermen that are active in bottom trawl fisheries in the study area. So I'm going to start to tell you a bit about my quantitative methods that were modeling and calculations. So I started with catch data that represents the current target species abundance in these wind farm areas and around the wind farm areas. And then to know how much the catch in the area would change after the wind farms, I used calculations of target species abundance change and then potential spillover effects. So I started by calculating the target species abundance change in protected zones. And I did this for different temporal scenarios after protection or after an offshore wind farm establishment. And I've used the previous study by Bergström et al. To do this. And when I knew how much the target species abundance would change inside the wind farm area after different yearly scenarios after construction, I could then calculate the spillover effect rate from the offshore wind farms for each of the year scenarios. And I've used the spillover effect rate from Haluani et al. To be able to calculate the amount of spillovers to the surrounding areas. And now when I had the amount of spillovers in the surrounding areas, I could calculate the new target species abundance in surrounding areas of the wind farms as well. So basically, the calculation on number 3 is the orange part here after offshore wind farm construction. So what I basically did was that I calculated how much is it possible to fish in the area after the wind farm is built compared to before. And that is number 4, change of total catch in the study area after offshore wind farm construction. So if this number is 100%, it means that the amount of catch in the area surrounding the wind farm is equal to the amount of catch that one could fish before in the whole area, including the wind farm area. And if it is like this, it would mean that the spillover effects help to regenerate the fish stocks in surrounding areas so much that it can fully compensate. So we will see later when we look at the results how it went. But first, moving on to the qualitative part of my methods. So after I had done these calculations and I had my results, I went on to interview local fishermen that are active in these wind farm areas and around the wind farm areas. And I wanted to hear their perspectives and thoughts on my calculated results. And I also wanted to see what they might see as opportunities and risks with establishing offshore wind farms in this area. As I said, I contacted fishermen and I found fishermen through web search and by some contacts that I had. And I contacted them by email or text message. And I contacted a lot of people, but I only got 5 replies. So I conducted 5 in-depth interviews that I then transcribed and coded and analyzed. Okay, so moving on to the findings. Let's start with the findings of the calculated results and change of total catch after an offshore wind farm construction. So the results of the calculations indicate that offshore wind farms might indeed help to regenerate depleted fish stocks in this area. The figure you see on the screen shows the modeled change of total catch for the area of all of the wind farms individually. We have them here, Mareld, Poseidon, and Westwind. And also for all of the wind farms, if all of the wind farms were to be built. It's the cumulative in the bottom of the figure. And you can also see that we have each of the year scenarios represented here. Blue represents 3 years after construction. The orange is 6 years after construction, and the gray is 9 years after construction. Yes, So as I said, if we reach levels here of 100%, it means that the target species available for catch would be at the same levels before and after offshore wind farm establishment, although a large area would be closed for fishing. And this is then thanks to the abundance increase and spillover effects from the protected zones. We don't have any values of 100% here, but the highest number we can see is 97%, so almost 100. This is around the Norway lobster fishery for the wind farm Poseidon, and this is for 9 years after an offshore wind farm construction scenario. But the change of total catch varies between wind farm site and different fishery, as you can see on the graph. So it really signifies the importance of doing studies on each wind farms and not look at general results for this type of studies. We can also see that after 9 years, the Norway lobster population available for fishing in the whole study area could recover up to 95% of their pre-offshore wind farm levels due to the spillover effects from the offshore wind farm zones protected from trawling. Yes, so even though it varies between the wind farms and for the different years, I would say this is quite positive results. It's important to note, though, that it depends on the species composition and the fishing effort and also the size of the area. And also here I have only included the catches that are up to 10 kilometers around the wind farms, so we don't really know what happens further out. So it is really important to consider these spatial differences in regenerative effects between adjacent offshore wind farm areas when planning and placing offshore wind farms. And it's important to consider it together with the management goals for fish stocks and the fisheries, and as well as the energy sector, depending on what kind of result one are interested in seeing. So, but definitely positive results, and this type of calculations is a way of quantifying the gain and losses of target species catch with different wind farm establishment scenarios. And I think we can conclude that the potential regenerative effects show positive trends during a 10-year period after construction of a wind farm. Well, however, the interviews with the fishermen show that the situation is complex. I showed them these calculated results and asked them about what they think about it and what they see as future opportunities, and also if they see any risks or any possibilities with this. And they are very cautious about the long-term benefits of offshore wind farms that were shown by my results, and they did not agree on the showed effects. They also expressed concern about safety risks, financial challenges, and problems with restricted fishing access that might lead to increased competition within the fishing sector and between the different fleets that are fishing in these areas. Many also revealed that their situation as fishers today is already under a lot of pressure and that they are financially bound to continue fishing. And since the establishment of offshore wind farms involves a lot of uncertainty and financial instability, it is therefore hard for them to see positive on change to other livelihoods and also to see other options. So if you're in a vulnerable situation, it might be quite hard to think of changing or converting to another type of livelihood. I, for example, suggested that they could maybe convert to fish with other gears that can be used inside a wind farm and is less harmful for the environment, or that they could convert their fishing vessels to vessels that can operate and work for the wind farm industry. But as I said, they were not really keen on these type of changes, and it's also very hard for them to change due to their financial situation. Many of the fishers also would like to continue with their commercial fishery if possible, but the uncertainty in this offshore wind farm process and the planning process of the offshore wind farms makes it really hard for them to both invest in the fishery as well as to take the decision to leave the fishing sector if that is what they might have to do. So many of the fishermen raised their voices around the planning processes around the wind farm areas, and they would prefer a more collaborative way of appointing energy areas than the process that we have around this today. And they also mean that they are not against offshore wind farms, but that they rather see them planned not in active fishing areas, but in other areas. So it's clearly a delicate issue with many vulnerable situations here. And we need clean energy, and offshore wind farms has been shown to be able to regenerate fish stocks, but the fishers are cautious and they see many risks with these establishments. But the thing is that if the stock trends continue as today, the fishers will have to change and be more limited in their way of fishing in coming decades anyhow, with or without wind farms. So if we want to continue fishing for future generations, we have to do it in a different way anyhow. And the findings from this study are important results showing how the offshore wind farms could be an incentive for conservation and regeneration of these depleted stocks. Coexistence is possible in theory with the spillover effects, allowing for the continuous fishing in the surrounding areas of the wind farm, but it would mean that we can only continue fishing in a more limited area and also with less boats. Passive gear fishing inside a wind farm is also suggested as a possible solution by many studies. It can work, and it then allows for a more limited catch, but still a sustained fishery that can be active for coming generations. So, as I said, coexistence is possible in theory, but the question is really then how to make change as good as possible also in practice without severe consequences for the fishing sector. So, for successful establishment of offshore wind farms and coexistence with the fishing sector, I have identified a few steps in the marine spatial planning process that needs to be improved. So, for example, when appointing energy areas in the marine spatial plans, better collaboration between the wind farm developers and the fishing industries is required. And it is the governments or the planning agencies' task to create these kind of platforms where collaboration can be undertaken. And by doing this together, spatial conflicts could be avoided as much as possible. But to be able to know how much one can compromise in a collaborative planning process, we also need clear management goals from government on really what to prioritize in the coexistence between clean energy and fisheries and the marine environment. So what should be prioritized over the other, and how should one think when trying to avoid spatial conflicts as much as possible? More open legal processes around these establishments is also an important step to make the possibilities of coexistence better. And also invitations to all the affected sectors to partake in this process is also key. It must be easy and clear to follow the process. Uncertainty today is one of the biggest issues that the fishing sector can see here when it comes to the offshore wind farms. So if we would have a more open processes that is more straightforward and easy to follow, that would also help to accept whatever result we might see, because it has been then easy to follow it from where we started the discussion to where we ended. And another thing that might help the coexistence is incentives from the government to support the fishermen in this type of potential change that they have to go through, such as economic compensation for potential transition of the fishing industry. This can also help the acceptance of change and help to see the opportunities rather than the risks. Yes. So, to sum up and to connect my findings back to the sustainable development goals, the offshore wind farms in Skagerrak can provide positive long-term regional effects on the fishing opportunities here in this area. And it does that in terms of spillover effects and abundance increase of target species in areas surrounding the wind farms. And this is thanks to the closure of bottom trawling and the protected zones that are then created by the wind farms. I.e., the study underscores the potential of offshore wind farms to contribute to the restoration of degraded marine ecosystems and the regeneration of fish stocks, which could lead to more sustainable fishing practices and less pressure on the marine environments. And that aligns with SDG 14, Life Below Water, while simultaneously also contributing to SDG 7, which is affordable and clean energy. However, realizing these environmental benefits will require that we address that we have significant challenges in the planning of these areas, and that we have challenges as well in the stakeholder engagement and the adaptation process of the different sectors that need to be changed. So these socioeconomic challenges highlight the complex nature of integrating renewable energy development with other existing industries, such as in this case, the fishing sector. And it emphasizes the need for policies that aligns with SDG 8 and SDG 14. But by developing strategies for enhancing collaboration between the stakeholders, we can contribute to SDG 17, that is partnership for the goals. So what we want to do is to make sure that the benefits of offshore wind farms are maximized while we are minimizing potential conflicts, right? So just some final remarks before I end this presentation. As I said before, it is important to note that there are spatial differences in areas that are adjacent. So it's important to do individual studies on each wind farm areas when trying to assess these types of effects. There are lacking studies as well on areas that have been approved and for wind farms and that are operating. And what is lacking is also the comparison between how it was before the wind farm was established and how it looks after. So both doing further studies on areas that are already considered for wind farms, as well as BACI design studies, before after control impact studies on the approved areas, is really important for future studies. And yeah, I think my study has shown a possibility of coexistence in 3 dimensions and how the offshore wind farms can foster a sustainable future that benefits both our oceans and coastal economies, and that also ensures that fish stocks are preserved for future generations, simultaneously as we produce clean energy. But as I said, this is not without conflicts, and I think it's all about to maximize the potential of offshore wind farms and minimizing the conflicts. So thank you very much for listening to my presentation, and I put a link here to the report that I wrote, and there you can also find all the references for everything that I said today. And I think now it's time for some questions, right?